This lesson is on quadratic functions. I'm just going to be introducing you to the idea of the parabola. We'll be talking a little bit about the equation and about the important parts of the parabolas. This equation right here is considered standard form. It's where y is on one side, and on the other side we have ax squared plus bx plus c. You'll notice that a is the coefficient for your x squared, b is the coefficient for x, and then c will be the constant term at the end. Okay, here let's move into the different parts of the parabola. Sometimes you have a parabola that's opening up, like the one over here on the left, and sometimes you'll have a parabola that's opening down, like the one over here on the right. We've already talked about that, and that has to do with whether or not a is positive or negative. When a is positive, it's going to open up, and when a is negative, it's going to open down. Let's label the important parts, starting with the vertex. The vertex is the turning point on the parabola. So for a parabola that opens down, it's down here, and for a parabola that opens up, it's down here, and for a parabola that opens down, it's going to be that top point. The axis of symmetry is the line that splits it in half. You've talked about lines of symmetry before, and so this is the line of symmetry, but we call it the axis of symmetry. It's the line that splits right down the middle, and you'll notice that the vertex sits on that line of symmetry. Let me move those over so they're in the right spot. Oops. There we go. So that's the line of symmetry. You'll notice it's a vertical line, and because it's a vertical line, it's going to be written as x equals and then a number. The same is true for this one. It's going to be x equals and then some number. That's what its equation is going to look like. A parabola either has a maximum or a minimum. If it opens down like the one on the left, if it opens up like this one, and the vertex is down here, then that is considered a minimum. It is the lowest point. And when we talk about the minimum, we're actually talking about the y value of that ordered pair, whatever that ordered pair is. If it opens down, like this one, then your vertex up here is a maximum. You'll notice it's the highest point. And again, we're talking about the y value. Then we have the y-intercepts. The y-intercept is where it intersects the y-axis. So on this one, your y-intercept is right here, and you're just going to have one. Over here, your y-intercept is right here, and you'll notice on both of them you can only have one, and you're always going to have one. With x-intercepts, it's every time it hits the x-axis. So for our first parabola, we have x-intercepts here and here. So on the first one we have 2, and on the second one they are here and here, and again we have 2. And we'll get into, we don't always have 2 x-intercepts for parabolas, and we'll get into that a little more later, but that's just the basic parts. You have the vertex here, then you have the axis of symmetry, you have the minimum or maximum. For this one it was a minimum. You have a y-intercept and some x-intercepts. Okay, now we're going to go through a few problems, and the first thing we're going to do is talk about the axis of symmetry and what it is. And we're going to graph these using the Desmos.com calculator. It's nice and precise. So let me pull up that calculator for you. Okay, here we have the graph for our first equation, and we're looking for that axis of symmetry. And we notice that it falls right down here, down the middle. Right through here. And the equation for that line, it's a vertical line, so it's got to be x equals. And if you notice what the x value is, it's -1, so x equals -1 is going to be our equation for that one. Let's see. So our first parabola for this equation, y equals x squared plus 2x minus 3, The axis of symmetry is x equals -1. Now we're going to graph this next equation, y equals 3x squared plus 6x minus 1. Okay, and that's this one here. And so you'll see again that if we draw the axis of symmetry right through the vertex, which is right here, the vertical line through there is also going to be x equals -1. Okay, these just happen to turn out the same. It's obviously not always going to be that way. Let's graph the last one. Y equals x squared. I have a mark in there. Y equals x squared minus 8x plus 15. Gives us this one here, and here's our vertex right here at 4, -1. So the line of symmetry through that line is going to be x equals 4. So when we graph it, we can look at the graph, spot the vertex, and we can tell what the line of symmetry is going to be. Okay, what if we don't have the graph? We need another way to find the axis of symmetry. And we have a formula. The formula for axis of symmetry is x equals -b over 2a. You want to star that. This is how we find the axis of symmetry. That's great. Where do the b and the a come from? They come from that first equation I showed you. Standard form is y equals ax squared plus bx plus c. So a is the coefficient, A is the coefficient for x squared, and b is the coefficient for x. That's where those two are going to come from. So let's practice calculating that for our top equations up here. These are the same three same three parabolas that we had before. And we're going to calculate the axis of symmetry, this time using the formula. So we're going to write the formula, x equals -b over 2a. Our b is 2 and our a is 1 because that x squared has a coefficient of 1. So x equals -b. We're going to plug in that 2 for b, so -2 over 2 times a. So 2 times, and we said a is that +1. So if we simplify, we get -2 over 2, which is -1. So x equals -1. And that's what we said up here, right, from the graph, was that x was going to be -1. Let's practice that again with b. On b here, our a is 3 and our b is 6. So we're going to write our formula. X equals -b over 2a. Some people say the opposite of b over 2a. If that helps you, you can write it that way instead, or think about it that way. So -b, if b is 6, that's -6 over 2 times a is 3, so 2 times 3. -6 divided by 6 is -1. So x equals -1. Again, that's what we had for b up here. On this last one, we should get x equals 4. So let's see if we do. We have an a of 1 and a b of -8. Be careful when you have that minus sign that it's part of b. So x equals -b over 2a. You'll notice I write it every time. That helps get it stuck in your head. So x equals, we have a -8, which we know is going to be +8 over 2 times a, which is 1. So 8 over 2, x equals 4, which is great. That's what we said it should be. So now we have two ways to find the axis of symmetry. We have the algebraic way using this formula, or we can look at the graph and find the vertex and use that method also. Okay, now what important part of the parabola was lying on that axis of symmetry? Well, when we look back, here was our axis of symmetry, and the important part that was on it was the vertex. So the vertex lies on the axis of symmetry. Well, how can we find the coordinates of the vertex if we don't, let's see, if we know the axis of symmetry? Well, if we have the graph, we can just look at the graph and find that it's 4, 1. But do you notice on that ordered pair that the x value is the same as the axis of symmetry? For this parabola, the axis of symmetry was x equals 4. And there it is that the vertex is 4, comma, something. The question is, how do we find y? Well, we know, the one thing we know about y, let's try that again, is we know y is equal to ax squared plus bx plus c. And for us, we have several equations where a, b, and c have been filled in. But if we know the axis of symmetry, that means we know x is equal to some number. And if we take that value and plug it in for x, then we can find what y is. And that's kind of hard to think about when you look at it with all the letters. So if that's a little bit confusing, that's okay. Let's do a practice problem and see if that helps make it make a little bit more sense. Okay, it says using the axis of symmetry, calculated above, find the vertex. So let's go ahead and write down what the axis of symmetry was for each of those. For the first one, it was x equals -1. For the second one, it was x equals -1. And for the last one, it was x equals 4. We're going to use those values and we're going to plug them in for x in order to find y, because we want to know what is y when x equals -1. So y is equal to -1 squared plus 2 times -1 minus 3. I'm just plugging x in right into that equation. So -1 squared is +1. 2 times -1 is -2, and then minus 3. 1 minus 2 is -1, minus 3 is -4. So we have our x and our y. We can write our ordered pair for the vertex. X is -1, y is -4. Let's go back and look at the graph of this equation. When we go back to our Desmos graph and we look at it, there's our vertex right there. -1, -4. So once we know the axis of symmetry, if we plug that number in, we can find the y value and find out what y is going to be, what the vertex is. Okay, on B, we would do the same set of things. We're going to plug in a -1 for this x and this x. I'm going to go ahead and square 1 in my head because I know -1 squared is 1, so that's going to be 3 times 1 plus 6 times -1 is -6 minus 1. So y equals 3 minus 6 minus 1. 3 minus 6 is -3 minus 1. Look, both of those have the same vertex, -1, -4. The last one I know is going to be different, so let's go ahead and do that one. We're going to plug in a 4 for x here and here to find y. 4 squared is 16 minus 8 times 4 is 32 plus 15. The less of this you do on your calculator, probably the better. If the numbers get really ugly, go ahead and grab your calculator. But you know, if you try to square a negative on your calculator, you have to use parentheses. So it's just a little bit more time-consuming and tedious to use the calculator when you can multiply in your head. So let's go ahead and subtract. 16 minus 32 is -16 plus 15 is -1. So our ordered pair for this last one is 4, -1, which we saw on the graph that that's actually where the axis of symmetry is. I'm going to end this one here and I'll do the exploring C on the next video.